It is differential equation season. So the first thing we're going to do is separate variables. So we can put everything with y on the left-hand side, everything with x on the right-hand side. So we're going to get dy over the square root of y squared plus 1, which is going to be dx over x. We can now integrate both sides. So the left-hand side would integrate to ln y plus the square root of y squared plus 1. I have a video showing how this happens, and it's a bit longer, so you can check that out in the playlists. But we should know that this is actually the same as the arc of sine h, so the inverse here. So sinha, who knows how you say it. So that is the same as that. The right hand side is much more simple. 1 over x integrated is ln x. I also have a video breaking down step by step how we get there. So we now use Euler's formula, since we know that sine ht would be et minus e to the minus t over 2. And we know that sine h to the minus 1 y would equal t, and that is the same as y equals sine ht. That kind of fits in, I just crammed it. So we can then get y equals sin h, or sin, who knows how you say it, ln x plus c. Let's now plug that into here, because we know that our t's are equal to that. So let's substitute that in. You're going to get e ln x plus c minus e minus all brackets ln x plus c. Divided it by 2. And that's going to be then simplified e to the c x using a few identities, and 1 over e to the c x divided by 2. We know that e to the c, well, a equals e to the c is greater than 0. So y is going to be ax minus 1 over ax divided by 2. We are now in a position where we can apply the boundary conditions. So we know that the boundary condition is y2 would equal 0. So if we now plug that in here, you're going to get 0 equals a dot 2 minus 1 over a dot 2 all divided by 2. And you're going to get a equals 1 over 4, a minus 1 over 4a, which equals 0. So a squared would be a quarter. If you obviously want to find out what a is, we're going to square root it. Now normally you'd have plus a half and minus a half, but we know up here that x is greater than a 0, or since a is greater than 0, so a would equal just a half. So now when we have a equals a half, I'm really trying to squeeze the last bit into here. You can plug this into our general solution, which is here, and that means you're going to get 1/2 x minus 1 over 1/2 x. So that's going to equal x over 2 minus 2 over x divided by 2. And our solution, can I fit it in here? X over 4 minus 1 over x. Bit of a trickier one, a bit more technical. But yeah, I have a playlist on differential equations, so check that out if this is a bit more complex for you. There are some first and second order homogeneous and non-homogeneous differential equations which are a bit easier.